Hello everyone. Since I didn't get to go over the mass to mole problems in class, I want to make a quick video showing you how I would go about doing these kind of problems so you can watch it before you do your homework to help you out. So let's take a look at this question. So this is kind of similar to what we've been doing in class. It's a combustion of propane. So what I'm asking for is, what is the mass of oxygen that is required to react with a certain amount of propane? So first of all, notice I didn't give you a chemical equation. So number one, first things first, is always get your chemical equation. So let's get it. There it is. You gotta do your chemical equation and balance it. All done and good to go. Now, next thing on to the next step. Number two is now we actually get into the calculations. And remember, we always start with our given. And in this case, our given is right here, 50.3 gram of propane. So this is our given. Now, why did I say step two is that convert all masses to moles? It is because it's a really good rule of thumb for you to remember that when you do any kind of calculations and you see mass or volume, it's a very good idea for you to convert everything to moles. Because when you have moles, you can actually use our good old friend, the chemical equation, to actually do a bunch of calculation with it, because the chemical equation tells you the different ratio between the moles of these reagents, all right, or these chemicals. So you have mass, you can't really use this equation to do your calculations. So that's why step number two is convert all masses to moles. Now it says all, but we only have one, 50.3 gram of propane. So indeed, that one must be our only one that we have to convert. So here we go. We always start with the given. You do the conversion. Now this is something that we did, or that you did, I think in the past, so I don't remember what unit it was, but it's just a simple conversion from gram to mole, and you use the molar mass to do so. If you've forgotten how to do the molar mass, I suggest that you go back and review how to do the molar mass. If you're really still very confused, come see me during office hour. You convert that gram into mole. There we go. So 50.3 gram of propane is 1.14 blah 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 mole of propane. Now there's a note there. I said don't round for sig fig just yet, because this is not the final answer. So that's also a good rule of thumb to remember. Do not round for sig fig until the very end. Otherwise that's going to mess up your final significant figure. Now after I have converted all masses to moles, I am now going to actually do what we've done in class, is use some mole ratios to solve this problem. Now, then I will take what I just got, this mole here, and now that's my new given. Right, my new given. I'm going to take it and I'm going to use it as my new given, and then do the mole ratio. I don't think you can see that. Maybe I can slide this down like so. Okay, there we go. All right, so now you do the same thing as we did in class, where the one that you want, you keep at the top. The one that you want to cancel, you put at the bottom of the fraction. So in this case, we want mole of O2. So we put mole of O2 at the top. And then we want mole of propane at the bottom, because we want to cancel mole of propane. Once again, how did I get these numbers? This number 5 is right here in the chemical equation. This number 1 is right here where this blank space is. Now there's no coefficient in front of propane, but you have to remember that there's an invisible 1 right there. That's how I get the 5 and the 1. So now that I have gone from mass to mole, and then mole of propane to O2, I can now convert the mole of O2 into mass of O2, because what are they asking you? They're asking for mass of oxygen. We got mole, but we don't have mass yet. So we do the same thing. We convert the final answer from moles to mass by using, that's right, the molar mass. So there you go. That's the molar mass of O2, and we get the final answer. Now, there's a little animation that tells you that you round for sig fig here because this is the final answer. And this one has 3 sig fig. The final answer has 3 significant figure. Now, you might be asking, Ms. Strong, why did we have 3 significant figure for the final answer? And I'm going to tell you that is because your initial, meaning your given, has 3 significant figure. So you base your significant figure of the final answer based on the sig fig of the original, of the given. Disregard any of these numbers where this is the molar mass that you have to use, and then also this one as well. See how this has 4 sig fig, but you know, because I already told you that the final answer must have 3 sig fig. So that means that you do not count these numbers towards your significant figure. Okay,